Algebra and Honors Algebra students, Mr. Lawrence here, and we've got a long video for you. It's going to be a review. This should be review stuff, but in case you didn't master it, here's going to be another opportunity. Make sure you watch this video more than once before Friday. Make sure you're paying attention, doing all your homework, thinking about what's going on. All right, so we're going to be talking about area, perimeter, circumference, volume, and surface area. All right, specifically area, perimeter of quadrilaterals, triangles, and then area of circles and circumference of circles. Now, we're also going to talk about volume, but we'll do that in a little bit later part of the video. First of all, you need to know that area is the space inside a 2D shape. Okay, the space inside. So the area of the square you see below there is the space inside. Okay? You got to know your definitions. Make a flashcard if you have to. Perimeter is the distance around a polygon. The distance around a polygon. Okay, so perimeter is the distance around a polygon. Okay. Now I didn't use the word polygon for area because circles have area, but they are not polygons. Now, circumference. Circumference is the distance around a circle. Okay. So I'm going to highlight in a different color here the perimeter of this square. It would be taking a walk around the outside of it. Okay, only the purple part is in here. If I can do that, so there's not three colors to screw you up. Okay, the area is the red part. The circumference is the purple part. Excuse me, not the circumference, the perimeter. Now, when I do area, I like to use one formula. I know that they taught you to use all these different formulas, and man, I just don't understand it. I like to use area equals base times height. Okay? Now I might have to adjust it a little bit, but this one formula works for squares, rectangles, triangles, trapezoids, parallelograms, rhombi, and even for circles. So check this out. Let's go down to this one here, and I'll get rid of my highlighting. This is a square. Okay, and I'll have to remark those sides congruent. But we do have a square. Let's do the perimeter first because it's so darn simple. When I do perimeter, I just take a walk around the square. So I'm going to ask myself, how far have I walked? Well, here I've walked 5 inches, haven't I? Now I've walked, and some of you are going to go 5 inches. No, I've walked 10 inches. Because from the start to here, I lost my line. I don't know where I went. I'm at 10 inches. And then if I go here, I've gone 15. And then 20. So the perimeter of this square, the perimeter is simple. It's just 20 inches. It's just inches because I'm going 5 inches plus 5 inches plus 5 inches plus 5 inches. 20 inches. You know, if I was counting dollars, $5 plus $5 plus $5 plus $5, that would be $20, right? Now, area is easy, but just a little bit different. The area of the square is going to be the base times the height. Super duper important. Super duper important. Please make sure you're paying attention to this. Area and base. I know you think you know the definition of base. It's the side the shape's sitting on. Please forget that. That's wrong. It's incorrect. It's not a totally useful definition. People use it, but it doesn't work in every situation. Area and base make a right angle. See this right angle I highlighted in blue? I know that the base is 5 inches and the height is also 5 inches. You're saying, well, Mr. Lawrence, it's sitting on that. Yeah, it is, but wait till you see how this works in some other situations, okay? So we're going to have 5 inches times 5 inches, and that's going to equal 5 times 5 is 25, but inches times inches. Inches squared. So your area is 25 inches squared. Now the rectangle is going to be done the same way. In fact, I'm not going to walk through it with you. I'm going to have you do it on your own. You can pause the video, My answer is going to pop up momentarily. Now look, too many of you are just watching the videos and not actually doing the problems. You're cheating yourself, and that's why you're having a hard time when you come into school. Okay? Go ahead and figure them out. Unpause it when you're ready. I got a perimeter of 30 inches, and I've got an area of 36 inches squared. Hopefully you got both answers. All right, let's go over this triangle here. It's an isosceles triangle. Now, some of you are going to go, hey, the base is 16 and the height is 17. That makes absolutely no sense. If you go to the doctor, here you are, okay, and you go to the doctor, and they're going to measure how tall you are. Do they measure down this way? No, of course not. They don't measure the slant height. They could make you 85 feet tall if they did that. When they measure how tall you are, they measure the distance perpendicular to the ground. And don't perpendicular lines, segments, make right angles? So you see, we have to get this distance here. The height of the triangle is from the highest point to the lowest point perpendicular to the ground. So, we actually don't know the dimensions of the height. Okay, we don't know the length of the height, the measurement of it. We have to figure it out. Tell you what, we'll do perimeter first because it's super easy. Perimeter is going to be 17 meters plus 17 meters, should take me up to 34 meters, plus 16 meters, which would be 50 meters. Okay, now to figure out how tall it is, I'm going to use the Pythagorean theorem. Yeah, Pythagorean theorem is so useful. Look at this right triangle right here. See it? See this right triangle? I got a right angle down there, right? Okay. I know the hypotenuse is across from the right angle, so my hypotenuse is 17 meters. Now, how long is the side of the triangle? Well, if this height is cutting it in half, which it should be because it's an isosceles triangle, this will be 8 meters. So I'm going to go a squared plus b squared equals c squared. I'm going to put my height as the unknown. In fact, I'll make it h. I'll go h squared plus 8 squared, and that'll equal 17 squared. Okay, and I'll do the Pythagorean theorem, and I'll get h squared plus 64 equals 289. And if I subtract 64 from both sides, I'll get h squared equals 225. Then, of course, I had to take the square root of both sides. And then h will equal 15 meters. Now that I know the height is 15, I can multiply the base times height. The only problem is the area of a triangle, base times height, isn't going to work. What is a triangle? Well, I'll bet you know that a triangle is half of a rectangle. It's actually half of any quadrilateral. You put two triangles together, you'll get some type of quadrilateral. If the formula for area of a rectangle is base times height, and a triangle is half of that, shouldn't my area formula for a triangle be base times height divided by 2? Yeah, it's base times height. This area, this area is going to equal base times height divided by 2. I could also say the same thing about this half, right? Base times height divided by 2. They're each half of the area. Together, they make base times height. All right? Okay, so let's go back to it here. All right, sorry about that. All right, so I'm going to do, here's my triangle. I'm going to do the base is 16 meters, right, because I need the whole base. The height is going to be 15 meters. And then I'm going to divide by 2. Let me see if I can do this in my head. 16 times 5, I think is 80? No. Yeah, 80. And then times 3 would be 240. 240 meters squared. And then, of course, divide by 2. And so that'll equal 120 meters squared. I'm pretty sure that's right. You can check me, and I'm sure Andrew Ozanich will let me know if I made a mistake. All right, now you see this rhombus here? Let's do the perimeter, because that would be real simple. Perimeter is going to be 48 centimeters. Okay? Now, to do the area, I'm going to use the formula base times height. But check this out. Let me send this guy to the back. I'm going to show you the height. Send to the back. There we go. There's the height, right? Now, if I could cut this triangle off of here and put him over here, I would make a perfect rectangle or square, wouldn't I? Yeah, it's probably going to be a rectangle. All right, I would make a perfect one. See that? It was a parallelogram, or actually a rhombus specifically. I cut it off here and I put it over there. Now, did the area change? No, the white part is just repositioned. It didn't actually change size, change the way it looked, maybe change the shape, but the actual amount of white area stayed the same. The space inside of it, it's just repositioned. So that's why I can use base times height. Now, remember, I need a right angle. Well, here's my right angle. I need my height. Now, I actually don't know the height in this case because I don't know the measurement of this piece here. So I'm just going to go ahead and tell you the height is 10 centimeters. Now, I want you to think, I wanted to tell you the height was 13 centimeters. That would be incorrect. See if you can tell me why. All right, so the area of the rhombus is going to be base times height. Well, the base is going to be 12 centimeters, and the height is going to be 10 centimeters. (120 centimeters squared). And there you go. All right. Just a coincidence that that area came out the same as the other one. All right. Now, a trapezoid is a different type of quadrilateral. It only has one pair of parallel sides, but it also can use the formula base times height. Now, please notice there are two bases. Watch, I can prove to you there are two bases in this one. If I cut that segment there, I can show two right angles, right? But you're saying it's not a trapezoid anymore. Well, hold on one second. Let me get the triangle so that you can see it. There you go. There's the triangle. Okay, so I drop that segment down there, and I get two right angles. So they're two different bases, and the bases are different lengths. But watch what happens if I move this triangle over here. Let me put that back in, and I guess I better show you a segment so my shape stays closed. All right, there we go. Now, if I rotate this 180 degrees, and then I reflect it left to right like that, boom, look at that. Let me send it to the back here, orders. There we go. And there it is. I have a rectangle in disguise. Now, what happened though? This piece here used to be 30, and it gained this amount here, didn't it? Now, this used to be 40, but it lost that same amount. I'm having a hard time drawing that little guy. Let me do it again. See, it lost that little bit. So the 30 increased by the same amount the 40 decreased. Well, the formula for the area of a trapezoid is so simple. If you think about it, if the 30, the one base, increased by the same amount the other base decreased, and now they're equal, I must have averaged them. So the formula for area of a trapezoid is to average the bases and then multiply by the height. So you don't have to memorize a new formula. You just have to realize two bases, and you want to equal them out so they can be treated like a rectangle. All right, now, let me send it back to where it was. Oops. Looks like my triangle disassembled itself. Sorry about that. Okay, there we go. All right, now, by the way, let's do perimeter first. Perimeter is so simple. Take a walk around the trapezoid. Take a walk around the trapezoid. So this side is 40. That's 13, so I'm up to 53. Go 30 more, now I'm at 83, and now go 13 more, 96. So the perimeter is 96 inches. Okay, now, to do the area, I've got to average the bases. Well, that's going to be 30 plus 40 divided by 2. I need to know how tall this is. Well, if you think about it, let's cut down this segment here. And this piece, sorry, I'm looking for my pen. This piece from here to here, this distance would be 30, wouldn't it? Because it matches the first base. Well, if the whole thing's 40, doesn't that force this to be 5? And it forces that to be 5 because 5 plus 30 plus 5 is 40, right? The whole thing is 40. Now this is 13 because they're congruent, and I need to use the Pythagorean theorem to figure out x. Well, I'm going to tell you that x is going to be 12 if you do the Pythagorean theorem. So I'm going to take this 30 times, or 30 plus 40 divided by 2, and I'm going to multiply it by 12. Okay, and so I'm going to have 35 times 12. If I triple 35, I get 105. If I double that, I get 210. And if I double that, I get 420. So the area should be 420 inches squared. And there you go. All right, now, a circle. For a circle, the formula is pi r squared. But I don't want to just regurgitate it from, that's the area. For circumference of a circle, it's pi times diameter. Okay, now, take a look at this circle here. I have 2 radii marked, and it almost looks like a square. And if I multiply a radius times a radius, I would get the area of a square, wouldn't I? In fact, let's bring the square over here, put it on there. If I multiply the radius times the radius, I would get the area of this, right? And now you might go, hey, there's 4 of those squares in there, right? You see 4 squares? I can see 4 squares. Let's see here. Let's see. Well, there's the second square, and okay, and there's the third and fourth squares, right? And they should be the same. If I fill that, it's a little bit off because of human error, but you get the point. Okay, here was, see, you can tell why it's off because that's too big. If I shrink that down just a smidgen more, oops, that's a little too much, then those things should match pretty well, perfectly. So let's just see if I'm right. There you go, that's looking a lot better. And that one, okay. Now the problem is, if I multiplied this yellow region by 4, I would get the area of the big square, wouldn't I? That's not the area of the circle. The circle is only this part here, right? This greenish part. Okay. And there are 4 of those, but I'm talking about the radius times the radius, which is the area of the square. So instead of multiplying by 4 to get the area of the circle, it's going to be close to 4. I end up multiplying by pi. Because remember, pi is approximately 3.14. Oops, I said 14 and I wrote 41. 1415, and it's an irrational number that goes on forever without repeating. So instead of multiplying this yellow area by 4, I multiply by a little less than 4, and that cuts away these little extra wedges here of the square outside of the circle that I don't want the area of, because oops, wrong color. I don't want the area of those. I want only the area of the circle itself, and these little yellow parts are not included. So I use a number a little bit less than 4. It's kind of crazy if you think about it, if you're paying attention, if you're not just watching, if you're really thinking about what I'm saying. This is really genius stuff. It's not my genius. I didn't come up with this. The people that came up with this is brilliant to think, oh, multiplying by pi will take care of that. It's just amazing. So to do the area of this circle, I'm going to do pi times the radius squared. Now you can use 3.14 for pi, or you can use the pi key. I think the OAA is going to have you use 3.14, and the radius squared would be 5 inches squared. Okay, that's going to be what? 3.14 times 25 inches squared. And that's going to come out to like 78 something. I'm going to let you verify what that is. Okay. Now to do the circumference, you're going to take pi times the diameter. And the diameter is twice the radius. Now, don't let this confuse you. On the OAA formula sheet, they are going to give you two formulas for circumference. They're either going to go pi times diameter or 2 pi r. Well, 2r is a diameter, twice the radius. So don't let that bother you. So this would be come out to approximately 314 inches. Okay, that would be the circumference if I'm using 3.14 for pi. All right, now we're going to change directions here. And I'm actually going to stop this video here and then make a second video, so I'll post them both. And it's going to talk about three-dimensional, just volume, not surface area, just volume. All right, so Mr. Lawrence signing off for now.